Section 7.5 is about multiplying and dividing rational expressions. Let's start with multiplying radicals. When we're multiplying radicals, friendly reminder that the square root of a times the square root of b becomes the square root of 8b. This would also work with cube roots, fourth roots, etc., as long as they are the same root. So you're going to need to either FOIL or use the distributive property. If I have the square root of 3 times the square root of 7 plus 5, that becomes the square root of 3 times 7, which is 21, plus the square root of 3 times 5, which is 15. I can't simplify what's under the radical any further, and they aren't the same radicand, so I can't add them. For 2, we're going to FOIL. Remember, FOIL stands for first, outer, inner, last, right? So I've got first, 3 times the square root of 2. Oh, I messed up. How did I mess up FOIL? So I go first, which is 3 times 5, plus outer, which is 3 times square root of 2, plus inner, which is the square root of 2 times 5, so we're going to have 5 square root of 2, plus last, which is the square root of 2 times square root of 2, which is the square root of 4. That gives me 15 plus 8 square root of 2 plus the square root of 4, which is 2. So I have 17 plus 8 square root of 2. Let's work through a couple more examples. Notice this first example kind of looks like the difference of a product, difference of a sum and a difference, the product of a sum and a difference, like we saw in chapter 8. Square root of 10 times the square root of 10 gives me the square root of 100. Square root of 10 times the negative square root of 3 gives me the negative square root of 30. Square root of 3 times the square root of 10 gives me the positive square root of 30. Square root of 3 times the square root of negative 3 gives me the square root of negative 9. So I get 10, my like terms cancel, minus 3. My final answer is 7. So all my radicals canceled out. Let's look at this final example. I've got 2 times the square root of 5 plus 2 times the square root of 3 minus 7 times the square root of 5. Well, that's going to be this negative square root of 35. Minus 7 times 3, well, that's the square root of negative 21, the negative square root of 21. Can I simplify this any further? No. So it could be the case that all the radicals go away and everything simplifies. It could be the case that nothing can be combined or simplified. One thing we really need to talk about is rationalizing denominators. Rationalizing denominators means getting the radical out of the denominator of a fraction. Just like we don't like negative exponents, in our denominators, we also don't like radicals in our denominators. So rationalizing denominators means removing the radicals from the denominator of a rational expression. Well, how am I going to do that? We do this by multiplying the numerator and denominator, because remember, if I multiply something into the numerator and into the denominator, it's really just multiplying by 1, and therefore finding an equivalent fraction. We want to multiply it by the smallest radical to produce a whole number in the denominator. Now, if I have a radical that can't be simplified any further, I'm just going to use that radical. So here, if I had 1 over the square root of 3, I would multiply the numerator and the denominator by the square root of 3. That gives me the square root of 3 over the square root of 9, so I'm left with the square root of 3 over 3. Let's try this again. For example 1, here I have the square root of 7 over the square root of 7. That gives me 3 square root of 7 over the square root of 49, which is 7. So I have 3 square root of 7 is over 7. And these are equivalent fractions. Let's try this again. I have the square root of 5 as my denominator. So I have 5 over 5 square root of 2 over the square root of 5. I multiply both sides by the square root of 5. I get 5 square root of 10 equals the square root of 25. So 5 square root of 10 over 5. Those 5s are going to cancel, so I'm left with just the square root of 10. Notice it says we rationalize denominators by multiplying by the smallest radical needed to produce a whole number. So we should always want to make sure we've simplified our radicals first. So I have negative 6 over 12, well, 12 factors into a 4 and a 3, so that's 2 square root of 3. You see I can pull out a factor of 2, so I have negative 3 over the square root of 3. I multiply by the square root of 3 on the top and the bottom, so I have 3 square root of 3, negative 3 square root of 3 over the square root of 3 times the square root of 3, which gives me 3. Now that's great when my denominator is just a radical, but what if it has more than a radical? We'll talk about that in a couple more slides. Okay, I'm going to go ahead and simplify this. This is negative square root of 18 over square root of 125. Remember, 18 is 2 times 9, so it's going to factor to 3 square root of 2. It's going to simplify to 3 square root of 2. 125 is 5 cubed, so this is going to simplify to 5 square root of 5. And I need to get this radical out of the denominator, so I'm going to multiply by the square root of 5 on the top and the bottom. That gives me negative 3 square root of 10 over 5 times the square root of 25. So I have negative 3 square root of 10 over 25, because the square root of 25 is 5. Let's try this again. I have the square root of 50m to the 4th over the square root of p to the 5th. Well, that's going to give me p squared, square root of p in my denominator, and 5m squared, square root of 2 in my numerator. And if you need a refresher of how to simplify radicals, go ahead and take a look at section 7.3. That's a great place to have a nice little refresher. I'm going to have to multiply the top and the bottom by the square root of p. That will allow me to get this radical out of my denominator. So I have 5m squared, square root of 2p over p squared, square root of p squared. So that gives me p cubed in the denominator. So I have 5m squared, square root of 2p. Now I had hinted earlier, well, what do I do if, for instance, I have a radical that's the square root of 2 over 5 minus the square root of 2, and I want to get rid of my radical, right, in my denominator. We don't like radicals in our denominators. So what we're going to do is we're going to have to multiply by the conjugate. So radical expressions that involve multiplying the sum and the difference of the same two terms are called conjugates. For example, if I have 3x minus x times 3x plus x, those are conjugates. If I have two radicals, right, if I have 5 plus the square root of 2 times 5 minus the square root of 2, this is our conjugates as well. And what happens when I multiply two conjugates together, okay, is that I'm going to get a squared minus b squared. We've seen this before, but let me show you what happens in the case of radicals. So I get 25 minus 5 square root of 2 plus 5 square root of 2 minus the square root of 4. Well, that means everything simplifies. I get 25 minus 2, which is 23, which is no longer a radical number. So let's go ahead and practice rationalizing the denominator using conjugates. Here's an example worked out, just in case you wanted to see it. So if I have 7 over 5 plus the square root of 3, and I multiply the numerator by the conjugate, which would be 5 minus the square root of 3, and I do that in the numerator and the denominator, that's going to give me 7 times 5 minus the square root of 3 over 5 plus the square root of 3 times 5 minus the square root of 3, which I showed you on the previous slide did answer to, oh, well, I guess I had the square root of 2. So that gives me 25 minus 3, which is 22, and I can go ahead and distribute this 7. So I have 35 minus 7 square root of 3 in my numerator. So there's a worked out example. Let's make some of our own. So if I have 3 over 1 plus the square root of 2, I'm going to multiply 1 minus the square root of 2. That gives me 3 minus 3 square root of 2 over 1 squared minus the square root of 2 plus the square root of 2 minus the square root of 4. So I'm going to have 3 minus 3 square root of 2 over 1 minus 2, which is negative 1. So I really just have negative 3 minus 3 square root of 2. which gives me negative 3 plus 3 square root of 2. Let's try that again. If I have 5 over 4 minus the square root of 3, I'm going to multiply on the top and the bottom by 4 plus the square root of 3. Again, that's the conjugate. We change the sign. That gives me 20 plus 5 square root of 3 over 16, because 4 times 4 is 16, minus square root of 3 plus square root of 3 minus the square root of 9, which would give me 3. So I have 20 plus 5 square root of 2 over 16 minus 3, which is 13, and my middle terms cancel. All right, let's try this again. Again, I have to multiply the conjugate. Square root of 5 minus the square root of 3. Even if there's two radicals, you still multiply by the conjugate. Oof, I got to FOIL the top and the bottom. This is going to be fun. Okay, so I have the square root of 25 minus the square root of 15 plus the square root of 15 minus the square root of 9. Oof, that gives me 5 minus 3, which is 2. This gives me the square root of 10 minus the square root of 6 minus the square root of 15. Negative 3 times a negative 3 gives me a positive 3. So my final answer is 3 plus the square root of 10 minus the square root of 6 minus the square root of 15. And that can't be simplified any further. All over 2.